Light moves fast, really fast. In fact, it is so fast that for centuries, people thought it traveled instantly from one place to another. It was not until the 1600s that we actually measured its speed, and when we did, we found something incredible. Light is not infinite, but it is ridiculously fast. Today, we say that the speed of light in a vacuum is about 299,792,458 meters per second, or just under 300,000 kilometers per second. That is fast enough to travel around Earth 7 times in a single second. This has led to one of the most famous rules in physics: nothing can travel faster than light. It is a fundamental limit, built into the laws of nature, based on Einstein's theory of relativity. But does this mean light is truly the fastest thing in the universe? Is there anything that can break this cosmic speed limit? Today, in Myths of Physics, we are breaking down the reality of the speed of light. What does it really mean for something to be the fastest, and are there any ways to cheat the system? Why is light so fast? Light is not just fast by coincidence. Its speed comes from something fundamental: the nature of space, time, and electromagnetism. Einstein's special relativity showed that the speed of light is the same for everyone, no matter how fast you are moving. If you are standing still or flying through space at incredible speeds, light still appears to move at exactly 299,792,458 meters per second in a vacuum. This is because light is made of photons, which are massless. Unlike objects with mass, photons do not have to push through space. They simply move at the maximum speed allowed by the universe. For anything with mass, reaching the speed of light would require an infinite amount of energy, making it impossible. So if light is the fastest thing in the universe, does that mean nothing can ever go faster? Not necessarily. When faster than light travel is possible, sort of. There are some weird situations where things seem to move faster than light. Here are a few ways this can happen, without actually breaking the laws of physics. 1. The expansion of the universe. Right now, the universe is expanding, and it is doing so at an increasing rate. Distant galaxies are moving away from us not because they are traveling through space, but because space itself is stretching. At large enough distances, this expansion is so fast that some galaxies are receding from us faster than the speed of light. That might sound impossible, but here is the key: these galaxies are not moving through space faster than light. Space itself is expanding between us and them. Since the speed of light only applies to objects moving through space, the expansion of the universe does not violate relativity. In other words, space itself is not bound by the cosmic speed limit. 2. Quantum entanglement, faster than light communication? Another strange exception is quantum entanglement. If two particles are entangled, a change in one instantly affects the other, no matter how far apart they are. Some people claim this means information is traveling faster than light. But here is the catch: even though the entangled particles influence each other instantly, no usable information is actually traveling between them. You cannot use entanglement to send messages or signals faster than light. So while it is a weird quantum phenomenon, it does not let us break the speed of light in any practical way. 3. Cherenkov radiation, when light itself breaks its own limit. Did you know that light can actually break its own speed limit, sort of? This happens inside certain materials, like water or glass, where light slows down compared to its speed in a vacuum. If a charged particle, like an electron, moves through that material faster than light can travel in that medium, it creates a shockwave of blue light called Cherenkov radiation. This is the eerie glow you see in nuclear reactors. But even though the particle is moving faster than light in that medium, it is still slower than light in a vacuum, so no real laws are being broken. Could we ever travel faster than light? Since the speed of light is a hard limit for objects with mass, you might think faster than light travel is impossible. But there are theoretical ideas that could allow it under the right conditions. 1. The Alcubierre warp drive. One of the most famous proposals comes from physicist Miguel Alcubierre, who suggested that instead of moving through space at faster than light speeds, a spacecraft could warp spacetime itself. By contracting space in front of it and expanding space behind it, a warp drive could move without technically violating relativity. This would let it reach distant places faster than light would normally take to get there. The problem? This idea requires exotic negative energy, which we do not know how to create in the necessary amounts. 2. Wormholes. Another possibility is wormholes, hypothetical shortcuts through space-time. If wormholes exist, they could let us travel from one point to another faster than light would take to travel between them. The catch? We do not know if naturally occurring wormholes exist, and creating one would require exotic matter that may or may not be possible to produce. So, is light the fastest thing in the universe? Yes and no. If we are talking about objects moving through space, nothing can go faster than light. The laws of physics simply do not allow it. But if we are talking about the expansion of space itself, quantum entanglement, or certain exotic physics ideas, there are loopholes that let some things appear to exceed the speed of light, without violating relativity. So, while light still holds the record for the fastest thing in the universe, the story is more complicated than just saying, nothing can go faster. Thanks for watching this episode of Myths of Physics. If you have ever wondered about other cosmic speed limits, let us know in the comments. And if you enjoyed this video, give it a thumbs up and subscribe for more deep dives into the science that shapes our universe. Until next time, keep asking big questions, and remember, space is full of surprises.